Hello everybody. Now we will talk about the logarithmic functions and integration. We have a theorem, we will use it to solve many problems. The theorem says, let u be a differentiable function of x, then the integral for 1 over x, here 1 over x, with respect to x is equal to ln absolute value of x plus c. By the same way, integration of 1 over u with respect to u, it is ln absolute value for u plus c. Here look for the derivative for x with respect to x is 1. The derivative for y with respect to the derivative for u with respect to u is 1. Which is mean if you have any fractional form like numerator over denominator or up over down or top over bottom, like if you have any function like u here and its derivative up with respect to x, this function is denoted or defined with the term x. U is a function of x. Okay, then if you have a function and its derivative up, this means it will be ln absolute value for u plus c. Then this is a general form for the theorem. How to apply this theorem? If you have any fractional form, like if you have here 3x and up 1 with respect to x, how to integrate this? Example, here 3x, its derivative is what? It's 3, but we have 1 up. Then you can multiply by 3 and divide by 3 out with respect to x. Then multiply and divide. Then 3x, its derivative is 3, u prime over u. This means it is third ln absolute. U here is what? Is 3x plus c. By the same way, you can solve many examples on this rule. Like what? Integrate. If you have here in the denominator here x squared plus 2x and up you have x plus 1 with respect to x. Here if you ask yourself what is the derivative for x squared, it is 2x. What is the derivative of 2x? It is 2. But in the numerator up we have x plus 1. Then we need to multiply x by 2 and 1 by 2. Then you will rewrite this form to multiply up by 2 multiplied by x plus 1 over x squared plus 2x with respect to x and divide by 2. Multiply by 2 and divide by 2. And rewrite the answer here. It is have here 2 multiplied by x, it will be 2x plus 2 over x squared plus 2x with respect to x. If you look for here the fraction, the derivative for x squared, it is 2x. The derivative for 2x is 2. Then up, derivative down, or numerator is the derivative for the denominator. Then apply the rule. It will be have out here ln what? Absolute value, the quantity down. Then absolute value of x squared plus 2x plus c. Okay. If you have another example, like integral for find integral for x squared plus x plus 1 over x squared plus 1 with respect to x. Here we have 3 terms up and 2 terms down. If you get the derivative for x squared plus 1, it will be 2x only, but we have up x squared plus x plus 1. But take care or look for the given. You have x squared plus 1 down here and x squared plus 1 up. Then you can rewrite the given, like you can write x squared plus 1, this term with this term, plus x over x squared plus 1. dx. You can form a group for the first two terms here and divide the numerator by the denominator. X squared plus 1 divided by x squared plus 1, it will be 1 plus x over x squared plus 1 with respect to x. And you can distribute the integral sign for the first quantity and for the second quantity. Here 1, what is integration for 1? 1 is a constant. You will multiply by the variable here x. The integral for 1 dx plus the integral for x over x squared plus 1 with respect to x. Here 1 is x. It is easy. But here x and 2x and x squared over 1. What's the derivative for x squared? It is 2x. Then you will multiply by 2 and divide by 2. Now up, derivative down. Now apply the rule. It will be half this constant ln absolute value for x squared plus 1 plus c. I think this is an easy way to get the answer. Another way, you can divide x squared plus x plus 1 here. You can divide x squared plus x plus 1 by x squared plus 1 by using the long division. You will get the same form here and apply your rules or your theorem here. Another example, number 4. Integrate x over x squared plus 1 with respect to x. I think it is easy example. Here x squared is the derivative is 2x. Then you will multiply up by 2 and divide by 2. Then it will be ln absolute x squared plus 1 plus c. But if he say evaluate the same function, evaluate the area of the region from 0 to 3 for the same function x over x squared plus 1 with respect to x. Then the same answer here, but here this is definite integral, but here indefinite integral. We want to find the area under the curve of this function and between the two vertical line x is equal to 0 and x is equal to 3 and over x-axis. You can draw the graph for this function and you can solve directly by applying this rule. Here you will multiply by 2 and multiply by half. Then you have out ln absolute x squared plus 1. But this is from what to what? From x equal to 0 and x equal to 3. And you replace this x by 3 and by 0, then subtract their values. It will be half multiplied by ln 3 squared, it is 9 plus 1, minus ln 0 plus 1, ln 1. And I think you can use your calculator to get the answer here. Okay, which is what? Which is 1.15. Okay, another example. If we have find number 5, find integral for 2x find integral for 2x over x plus 1 all to the power 2 with respect to x. Here x plus 1 all square, if you expand it you will get 3 terms, x squared plus 2x plus 1. and up we have 2x only. Here you can substitute about the value for x plus 1 using u. Let u is equal to x plus 1. This means the derivative for u will be du dx, okay? Or du is equal to dx. And here x is equal to u minus 1. Now you have everything with respect to u. You can rewrite the question here. 2x, it will be 2 multiplied by u minus 1. Here's 2x, x is equal to u minus 1. Okay, over x plus 1 is u, then this is u squared. Dx is du. Now you can solve now. 2 is a constant, get it out here. Integrate u minus 1, divide u over u squared, minus 1 over u squared, all of them with respect to u. 2 is a constant here. U over u squared, it will be integral for 1 over u du, minus integral for 1 over u squared, it will be u to the power negative 2 du. Use the exponent rule. Now 1 over u, I think the same form for the theorem here. It will be 2 ln absolute u. Minus u square u to the power negative 2, apply the power rule, add 1, then multiply, then divide by the new power. Negative 2 plus 1, it will be negative 1, divide by negative 1 plus c. Then simplify, it will be 2 ln absolute u, which is x plus 1, minus u power negative 1, negative by negative will be positive 1 over u, x plus 1 plus c. Thank you for watching.